Here we go. Okay. Let's do one more thing here while I'm on top of it. Let's call up the calculator so I have it ready. Okay. Here, and we'll let it go. Okay. The National Retail Federation commissioned a national survey on November 26th through 28th, 2009. A random sample of American adults. Okay, so this is a good thing to know right here, that it is a random sample of American adults, were asked about their Christmas shopping behavior on Thanksgiving weekend. Among the 2,597 respondents who said they had done some Christmas shopping that weekend, the average amount spent was reported to be $343.31. Okay, so the scenario gives us a lot of information. So, so let's start out here. Is 343.31 a parameter or a statistic? Who gets to answer? Wait. Oh, I know what I did wrong. I was color coordinated, but both stats classes are yellow. So I thought this was tomorrow, and it's not. It's today. This is period 4. Sylvia's not in this class. Alondra's not in this class. I could have been calling every single name in the magic bowl and would not have gotten anybody. My probability of finding somebody was 0. No, my probability was a little bit because there's an Isabella in the other class, but no other similar names. Okay, so Kathy, is this 343.31 a parameter or a statistic?
It's a statistic because it's based on the sample that they used.
Because it's on the sample, it's a statistic, it's from the sample. So what do we use to indicate the statistic? What symbol do we use? Don't feel bad, I was struggling with it too. Go take a look, that's fine.
I think it's X bar.
It is X bar. X bar is the mean, the symbol we use for the mean when it is a statistic. So X bar equals 343.31. Okay. This is a question. Okay. Identify the parameter of interest for this study and the population of interest. So remember that what we're doing in statistics is we start with a population, we take a sample, S-A-M-P-L-E. From the sample, we get a statistic. And then from the statistic, if we do everything correct up till then, we get a parameter, which is what applies to the population. So a statistic is to a sample like a parameter is to the population. So what are we looking for in this study? What do you think we're gonna be trying to figure out? What is the parameter we're going to be trying to figure out, and what population is that going to apply to? Right. So let's try the magic ball. This is a tough question, but let's see. Susie, you got an idea?
This is a guess, but maybe the parameter is American adults.
That is the population. So that you're kind of on the right track. We're trying to find out something from looking at this sample here. We're trying to find out something about American adults. what do you think we're trying to find out about American adults?
If they spent, if they went shopping, Christmas shopping on Thanksgiving weekend.
I think you're getting closer. You're getting closer. You're getting closer.
Is it the amount they spent?
Yeah, that's good. We're trying to find the average amount that Americans who went shopping over Thanksgiving weekend, how much was the average amount that they spent, right? So what symbol do we use for that? I'll take a volunteer. What symbol do I use? I'm trying to find the average amount that American adults who shopped on Thanksgiving weekend spent. What symbol do I use?
Is it mu?
It is mu. Mu. Yes, it's the cow symbol. It's mu, right? That's the average for a population, and we're trying to find out, well, what is it? And the population that we're looking for is all American adults. Now I'm going to quantify that. And this is a little bit picky, but it's important. All American adults who went shopping Thanksgiving weekend. It's important that we specify we're looking for the American adults who went shopping Thanksgiving weekend, because I'm guessing there's a ton of American adults that did not go shopping on Thanksgiving weekend. Right, and so their amount would be 0, and then that would like pull our results like way to one side for the average. You follow what I'm saying here? Yeah. So it's they're pretty clear up here in the scenario that they were asked a random sample among the 597 respondents who said they had done some Christmas shopping. So they had done some Christmas shopping. That's what we were looking for. People who had done some Christmas shopping. Okay, that's fine. I just got a chat and not a problem. Although that's good. Okay. Okay. So let's continue. Okay, so we're letting mu denote the mean dollar amount, the average dollar amount spent on Christmas gifts that weekend in the population of all American Christmas shoppers. Okay, so it's important that we're looking at the Christmas shoppers. And we're going to let sigma represent the standard deviation of those amounts in the population. Okay, so, nothing new here. Mu is the mean and sigma is the standard deviation. So, does mu necessarily equal 343.31? How many people say yes? Oh, what? You can say, what's going on here? I'm like, start video. Were you able to see me before, or were you just looking at me with the hat on? Just me with the hat on? Why nobody says anything? Oh, my goodness. I don't turn off my camera, generally speaking. Yeah. Okay, so does mu necessarily equal 343.31? Yes? No? I'm asking for votes here. Does mu necessarily equal 343.31? How many people say, yeah, of course it equals 343.31? How many people say, no, it does not equal 343.41 necessarily? It does not. That's right, because sampling variability, right? This 343.31, that is from a sample of 2597. N equals 2597. That's a big N, right? So sampling variability. Variability. Okay, good. Now, if mu was really equal to $350, so the population average was actually $350, is it possible that we could get a mean from our sample of 340, 331? Is that possible? If the average for the population overall, can we get a sample mean from our 2597 respondents of 340, 331? Susie, what do you say?
I think yeah.
Well, I think you should say yeah without the question mark. Yeah, sure. Why not? You know, I mean, yeah. But Susie, what about if mu was 400? Could we then have gotten a sample of 340, 331?
Yes.
I think so too. I think so too. I'd say less likely, but I think it's possible, right? Isabella, what about if mu was actually 600?
I think it's still possible, but like really unlikely.
I think you're absolutely right. I think it's still possible, but really unlikely. You know, I could flip a coin and get heads, 15 times in a row. It's possible. Very unlikely, but absolutely possible. Okay, good. Okay, so we are going to assume for now that mu is 350 and that sigma is 150. So we're going to make the sampling distribution. We're going to say, okay, if that is the case, well, actually, I should have, that's a pretty good, no, that's okay. I need to do my test to see if the central limit theorem applies. But if you remember, the test is n greater than or equal to 10. And is everybody clear that my n is equal to 2597? Is that clear? That has to be very clear, right? That's my sample size. I took a survey of 2597 American adults. That is my sample size. That's an N, not an A. Make that an N. That's better. Yeah, that's my sample size. Well, that's certainly bigger than 10, so I'm pretty comfortable with that. Okay, so so right in the middle here, I'm going to have, it says, assume for now that mu is 350. So I'm assuming that my mu, my mean is 350. And it says my standard deviation is 150. So do I do this? 1, 2, 3, 1, 2, 3, 150, that would be 500, 650, 800, and then this would be 250, and then somebody's going into debt here, negative 100. Is that correct? That is not correct. That is wrong. Very wrong. That is wrong because this is a sampling distribution. So when I want to find the standard deviation of a sampling distribution, I still start with my 350 in the middle, but I have to calculate the standard deviation. The standard deviation is going to equal sigma divided by the square root of n. So it's going to be 150 divided by the square root of 2597. So my standard deviation is actually 2.94. I can't emphasize enough how important this is to remember. You're just going to get it completely wrong if you don't remember to calculate the standard deviation for the sampling distribution. This 150 is for the entire population, and it's saying the entire population of American shoppers on Thanksgiving, and it's saying a sample size of 1. So between, if I pick one person out at random and another person out at random, and I average how much they spend, and then I do it a bunch more times, but I'm only taking one person at a time, the average difference between them is going to be $150. But I'm not doing this for one person. I'm doing this for a sample size of 2,597. So there's going to be a lot less variability between one sample of 2,597 and then the next sample of 2,597 and then the next sample of 2,597. There's going to be a lot less variability. It's going to be a lot closer to the actual population mean of 350. So that's why we have a standard deviation of 294. So now we have, well, I'm not even going to try it, 350 plus 2.94 plus 2.94 plus 2.94, and I get 352.94. I get 355.88, and I get 358.82, 358.82. And then going the other way, 350 minus 2.94 minus 2.94 minus 2.94, 347.06, 344.12. You hear the cat? Hear the cat in the background? Yeah, just getting ready to get fed. And then 341.18. And let's make this one look a little bit better. 344.12. 44.12. Okay, so there's our diagram, and the axis, the x-axis here is average spent Thanksgiving weekend and I'm going to put n equals 2597. So that just indicates our sample size. But this is the average that a sample size of 2597 would have spent on Thanksgiving weekend, given these parameters here of mu being 350 and sigma being 150. So how we feeling about this? We feeling pretty good about this? Yes, people with your cameras off, at least give me a thumbs up or something, okay? So everybody else, I can see them nodding their heads. So yeah, I'm doing okay. Okay, all right, good, let's continue. Why is it reasonable to assume a normal shape, even without knowing the shape of the distribution of expenditures in the population? Okay, so I'm gonna comment on this. It's a normal shape because n is greater than 10. Everybody okay with that? So even if the underlying population had a skewed distribution, which I would kind of assume if we're thinking about spending on Thanksgiving weekend, I'm kind of thinking it probably would be a skewed distribution, because you're going to have of that population, because you're going to have, a bunch of people that really, can't afford to spend that much. And then you're going to have, this is like a lot of money here. You're going to have a handful of people that are going to be able to spend like a real lot. I would think that that's going to be skewed. But the fact that my n is greater than or equal to 10 is telling me when I do a sampling distribution, it's going to be unimodal and symmetric. It's going to be normally shaped. So let's calculate a z-score. Michaela, you there? Yeah, hi, Michaela. What formula do I use to calculate a z-score? Can you tell me the formula? Okay. Well, we'll push on here. Isabella, what formula am I going to use?
Would you use the standard deviation over the square root of n?
No, that's how I calculate the standard deviation. I want to calculate the z-score for what I got from my sample of 343.31.
Oh, okay. Would it be 343.31 minus 350 over
What was it? 2.4 something?
yeah,
2.94 over 2.94. Z equals that. So this is Z equals X bar. That's what I got from my mean from my sample. Minus, no, I'm sorry, X. Yeah, Mr. Jenkins, stop it. You're recording this for everybody's going to hear you making mistakes. X minus X bar over S, right? Okay, so let's do that calculation. And we find out a z-score. I have 343.31 minus my assumed mean of 350 divided by 2.94. I get a z-score of negative let's call it negative 2.28. Negative 2.28. Let's put that on my diagram and see how that looks. What was it? 343.31. Let's write that down here. X bar equals 343.31. Yeah, and that's over here someplace. So my z-score negative 2.28. Yeah, negative 2.28. That's between, -3, -2, -1, 1, 2, and 3. So it's between -2 and -3. So I think I've calculated my z-score correctly. Everybody okay with that? Yes, I'm seeing yeses. Good. Okay, so let's keep going. Well, so is it surprising to obtain this mean from my sample when the population mean equals 350 and the population standard deviation equals 150? So in other words, is this a surprising result? Well, I think for me to determine that, I would like to know, now let me think, how am I going to do that? I know I'm negative 2.28 standard deviations away from the mean. I think what I would like to do here is find out, I'm going to find out what is this probability right here. Because it seems kind of low to me, and that seems kind of far away from the mean. In fact, let's just use the empirical rule for a second. I know that between -2 and 2, this is a good thing to talk about. Between -2 and 2, see, it's 68, 95, 95% of all data values are between -2 standard deviations and 2 standard deviations. Everybody okay with that? That means only 5% is left. There's only a 5% probability that I'm going to be outside of -2 of 2 standard deviations from the mean. I will say that again. If 95% of all the data is between -2 and +2 standard deviations, that means only 5% can be over here or over here. right? In fact, since it's unimodal and symmetric, what it means, listen carefully, is that there's only a 2.5% chance that I would get something less than -2 standard deviations. You follow what I just said there? Yeah. So I'd say this is a surprising number then. I mean, that's not a very big probability of getting that low of a number. It's less than 2.5%. Do I need to say that again? I want you to be really clear on this. Questions? Speak up, put it in the chat, whatever. No? Everybody's totally clear, 100%. Okay, good. All right. So then I'm saying, yeah, I didn't even need to do, I was going to do my calculation, you know, on my normal CDF, but no, I think it's surprising. I think that's too low of an average. If the actual population mean is 350, I think that's too low of an average. Let's see what they're going to ask me next. Oh, they want us to use 340 as a population mean. So, well, let's talk about this together here for just a second. I want to use 340 as a population mean. So they're saying change this right here to be 340. Will my standard deviation change? Will my calculation of my standard deviation change? I don't think so. Because they just said try a different mean. They didn't say try a different standard deviation. They just said try a different mean. And the standard deviation for a sampling distribution is standard deviation divided by the square root of n. Standard deviation is the same, n is the same. It's still going to be 2.94. So let's see what it looks like. Let's do what they asked and see what it looks like. So here is my normal model. Here in the middle is now it's 340 instead of 350. My standard deviation is 2.94. So I have 1, 2, 3, -1, -2, -3. A calculator. So 340 plus 2.94 plus 2.94 plus 2.94. So I have 342.94, 345.88, and 348.82, and then 340 minus 2.94 minus 2.94 minus 2.94, and on this side I get 337.06, 334.12, and 331.18. All right. Now, what was our value that we're looking for here? What is it? 340. What am I? 343. 343.31. So my X bar is 343.31. Well, now it looks like it's going to be over here. Let's make that a different color. So let's calculate the z-score. Z equals 343.31 minus 340 over 2.94. So I have 343.31 minus 340 divided by 2.94. Well, that's a z-score 1.125, 1.126 actually. And that to me seems a lot, well, that seems a lot better guess, doesn't it? Seem better, more reasonable that we could have gotten that, right? Because yeah, I think that's a lot more reasonable. Does that make sense to everybody? It's closer to the mean. It's closer to the 340 that is our hypothesis. So yeah, so I would say that is because the justification is because it's closer to the mean. Much more plausible. So do you notice the similarities between this and what we were doing yesterday or 2 days ago with the proportions? They're very similar processes. Can you see how similar they are here? Right? But you have to, in order to know exactly which one to do, you have to know whether the variable is a quantitative variable, the underlying variable. Is it quantitative or is it categorical? That's really what determines which one of these two methods you use. Now, I will point out one thing that is different, which I was really just thinking about as I was doing this problem. When we just changed the mean here from 350 to 340, the standard deviation stayed the same. It did not change. But with categorical variables, when I changed pi, that did change the standard deviation. I had to recalculate the standard deviation, right? Because the standard deviation for categorical variables is pi times 1 minus pi over n and take the square root, right? But for this quantitative variable, it's the standard deviation divided by the square root of n, and changing the mean is not going to change the standard deviation. Pretty good? Are we kind of doing okay here? Yeah? Okay. Okay. So this is an interesting question. Assume we don't know the value of mu, which of course we don't know. We were hypothesizing. We were first hypothesizing that mu was 350, and then we were hypothesizing that mu was 340. But if we know the standard deviation of the sampling distribution, we're asking the question, how close to the population mean do we expect the sample mean to fall? And this is where we're going to the empirical rule, and we're going to 95%. So if we want to say something about how confident am I, if I have a sample statistic that falls within a certain distance of what I'm assuming as the population parameter, then I can say I am confident that the population parameter is within that distance of the sample statistic. You know, I really don't like the way this is said. And we're going to learn more about confidence intervals actually in the next section here. So I guess what I want you to get from this, and I wouldn't expect it to show up on the next test, but if I hypothesize a mean, in this case 340, and my sample, which was 340, 331, falls within 2 standard deviations of that mean that I have hypothesized, right? Then I can say I am 95% confident that I really hate the way this is coming out. I can say that I'm 95% confident that this sample mean that I hypothesized is somewhere between 334.12 and 345.88. Do you understand what I'm saying here? If I have this sample size and I've hypothesized this 340, I can kind of say that that I am confident that my population parameter is pretty reasonable because I'm within these 2 standard deviations. You know, I really want you to listen to what I said and just kind of get a very vague idea of what I just said about confidence, and then just kind of don't forget about it, because it'll kind of come up in the next chapter, which will be a lot more clear. Okay. So let's stop this for a second. Come on.